Yes.
Today we'll talk about chapter 10 thermodynamics, section 1, relationship between heat and work. So the first idea in the lesson is that internal energy can be used to do work. So work can increase the internal energy of a substance. And internal energy can be increased or decreased through the transfer of energy as heat. Okay? And energy can be transferred to a substance as heat. And this internal energy can be used to do work. So here we relate heat and work together. So on a microscopic scale, heat and work are similar. Both are defined as energy that is transferred to or from a substance. An object that never has heat or work in it, it only has internal energy. Now we will know what's the system and what's an environment. System is a set of particles or interacting components considered to be a distinct physical entity for the purpose of study. These systems are really isolated from the surroundings, so we have something called environment. It's the component of conditions and influences outside the system that affects the behavior of the system. So we'll take the work formula, but in gases only. So this is the work formula. We have pressure and change in volume, and only gases. And lastly, when we have a positive change in V, it's expansion. When we have negative change in V, it's compression. And when we have no change in V, no work done. Because work depends on volume, not on pressure. So finally, we relate internal energy, heat, and work together. So processes that involve work only is very rare, and only heat is also very rare. So in most cases, energy is considered as both heat and work. It's not considered as one of them only. However, in some processes, one type of the heat or work can be very negligent. So we don't account it and we compare it to ideal process. And all objects have internal energy, but in non-atomic gases, molecules are far apart to interact with each other. So all of the internal energy is kinetic energy.
Okay, thermodynamic processes. Thermodynamics is the science of relationship between heat, water, temperature, and energy. We have three types of thermodynamic processes that we can see in the next slide. And thermodynamic processes are generally affected by internal energy, water, and heat. Okay, isovolumetric process. Can you read that?
Isovolumetric process, a thermodynamic in which the volume is constant so that no work is done on or by the system. Energy is transferred as heat only. Example, when we transfer heat to the pot to the screen, it's an isovolumetric process since the temperature increases in water. Increase in water is done at a constant volume.
So isovolumetric process is the volume is constant while you have energy transfer as heat. As the example here, the water temperature is increasing but the volume is constant. Second one, isothermal process. Can you read Ram?
Yes. A thermodynamic process that takes place at constant temperature. In this process, we have no change in temperature. During this process, outside pressure is equal to inside equilibrium pressure state. Example, here in this figure, heat is applied but temperature is not changing until the water changes phases.
So, isothermal process, we have constant temperature and also pressure. In the example down, the water phase is not changing, it's still liquid, while heat is increasing. Adiabatic process. Can you read? I have
a process in which no heat transfer takes place. This happens when energy leaves from a system due to work being to the system. Example, this figure work as pressure is applied to the air molecules which causes them to act a work in the container wall while heat is constant.
So in this type, we have no heat transfer outside or inside the process. Only pressure is being increased. Yes, we can.
Thank you, guys. Thank you.